In this chapter, we focus on a topic of functional programming, which in all programming languages helps us to create smoother programs, which are more complex in nature. Here we have our computer science objectives for this week. Notice there are no media objectives in this chapter. Here are some considerations when choosing how to write your function or functions, or even what function to use. As mentioned, functions can be complex in nature. The size or length of our function depends on what we need the function to do. Using functions helps complete tasks for us in a smoother way. So, of course, it has its advantages, as listed here. You'll notice the code on the left is much smoother than the one on the right. One function creates an entire web page instead of 4 functions creating different parts of a web page. Our code on the left is still better because we are creating a web page. On the right, we are creating a text file labeled as homepage.html, missing our important HTML tags. Using print statements, you can test what each function is doing to see where any errors need to be debugged. You will notice, based on our second example in slide 7, once you assign parameters to these functions and print, you will see their results. We previously defined doctype, but are redefining our other functions here. Functions can be overused. It is important to only use additional functions to make your program smoother. Put comments above your functions to show what they do. If there is redundancy, you do not need that function. On the left, we are using one function to create a web page. On the right, we are using 10 functions to create single parts of a web page. Which looks smoother? We again are passing parameters to our function to print them. This is why comments are so important. You can tell someone what the function's intention is, and they can tell if the function meets this need based on your code. Other people can look at your code and determine whether it is appropriate or not, especially if they're experts or are more knowledgeable in the area of computer science than you. Here again, our code on the right is technically smoother, but requires 3 functions to do the work of one function on the left. Comments, as mentioned, are very important if you write out multiple functions for one function because a file is being created in this example, so the entire program must run. Using subfunctions can be helpful once you are familiar with and understand what your function is doing. As you have previously seen, loops can be complex in nature. It may be appropriate to remove certain information from a loop and use a function instead. Compare our code here to the code in slide 16. You will notice everything in the if file.ends with JPEG statement has been extracted and put into a function. A slight modification to the code makes it easier to troubleshoot. There are no restrictions to how your code looks as long as you follow coding standards. The goal is to write the code for its intended purpose. Length is not an issue for beginners. As noted, using the print statement makes it easier for you to properly debug any issues within your code. Here, we return images 100 by 100 within our file. Here we are testing what our functions do. Our output via print gives us a paragraph tag with our file name and location or hyperlink reference with height and width as defined. We always want to break down our code into tasks. If the tasks do not relate, then use different functions. Think of procedures as a to-do list and put each procedure in order of its importance. Here, we are suggesting the need for 5 functions and one of them has a subfunction. Can you tell which one has the subfunction? It should be obvious. Create the body function has the subfunction process each JPEG. Here, our function with the subfunction now will have 2 subfunctions to include music files. You'll notice we now add process each wave file. Can you spot the difference between music and picture files here? We don't need height and width for our music. Our code will generally change if our tasks change. Here, we are just finding our media files. Here, we are seeking certain size pictures and certain length on our music files. Our file shows our music and images which meet the restrictions previously defined. While our program does what we need, expert programmers may try to break down a program so each function has its own task. Here, you'll notice a subfunction for our 2 subfunctions. This is a sub-subfunction. Can you identify the sub-sum function? It is our define file entry. Using the print statement allows us to debug issues. We've stated this over and over again. But you can also use comments to describe your function. Here we see an example file based on our previous code. Ideally, when coding, your code should address all related problems. Therefore, it can be reused to address multiple questions. Here is a reminder as to why we want to use functions. Once you have a grasp or a firm grip on programming, you can reduce the length of your code using these shortcuts. Functions can be used as input for other statements based on their data definition. Here, instead of just printing hello Mark, we can use the apply statement to use the function hello to say hello Mark and hello Betty. Notice this may not be the best example of using apply. Here, map, using an array of names, allows us to print out multiple names at once. This statement map has clear implications of why it should be used. Think of filter as a Boolean to some degree. Boolean returns true or false. In this example, January has 1 R and July has 0 R's, so they are returned. For the names, only Mark has an R, so only he is returned. These are similar to using wildcards in Microsoft Access within a query. if you have done so. Think back to our example in slide 44. Notice instead of two if statements, we have one return, which gives us the same result since Mark has an R in it. The reduce statement combines results. The words in this slide notes our reduce statement combines everything within our array. All of these words on the side simply say that 1 is being added to 2, to 3, to 4, to 15 to get us our total of 15. As you notice in the last slide, add serves no purpose. In the function, we don't need it. Instead, we can write the same program from slide 47 with much less code, as seen here. Calculators in Excel have made it easier for us to do math. Python programming can do the same. As mentioned, apply is less helpful than map and filter, but can still be helpful if applied correctly. Functional programming is a goal for programmers to make their programs more efficient. Here you have an extensive description on functional programming. As mentioned on the last slide, these are big data resources. But what else are they? Here we have a function turning pixels red. You've seen this before in our previous chapters. Now we turn red into a functional program on the left. Using our map function, we can make our code one line. Here, we retrieve our picture to edit it. Can you rewrite the code to use lambdas instead? Try it out. See what you come up with. Functions help address your tasks in the smoothest way possible. This generally means less code. There are times we want to change our inputs, but more often than not, we do not. So they stay in the current state. Here, one of our functions from chapter 4 has been edited so that our input is not changed. Similarly, we change another function so we don't need to change our input. A nested function is a function inside another function. In this case, decrease red, increase blue with the parameter p is a nested function. Here we have a nested function. Here we have a nested function. The repeated application of a procedure. That is the simplest way to define recursion. Our lists or arrays influence recursion. Here, our list refers to itself. Notice how this would likely only work on smaller images. Recursion is often taught in a higher level programming course due to its complexity. This function, as seen, shows hello initially, then breaks it down by letter, then adds the letters back to get hello again. Notice how it is down up. You will see a difference when we do the opposite. These are common ways to understanding recursion as detailed throughout the rest of this chapter. Again, think back to the to-do list where we put items in order of their importance. We set our word as I, as in I am old in this example. You will notice our down-up lists are shorter based on less characters. Our output grows based on our number of characters. We have not defined our word yet. Here, we define word and receive a Stack Overflow error, which prevents our program from running fully. When there are errors, you will often be informed where you have an error. In this instance, the error in our code is on line 58. Here, our length acts as a stop within our function. Notice, once we get to just an O, we finish the program out rather than seeing the error in slide 76. Tracing is just like writing everything out. Think back to our recipe simile. If you don't have the recipe written down, you must memorize it, which is very hard. We continue to write everything out. Here is the bottom half of what we want our output to be. Elves tend to work hard to complete a set task. Pick a word which will work for this function and test it out. Why is up down different than down up? Can you tell the difference? Subfunctions and sub-subfunctions are common in using recursion. Sometimes you need to import classes for your program to compile correctly. Notice here, we are importing OS. We are importing java.io class. Here, our function prints all files in the defined sample folder. All of our documents, sample folder here. This may not run as efficiently as our loop from chapter 4. A global function can be referenced anywhere in your code, unlike a variable defined within a function. Here is a reminder of why these advanced programming topics are helpful. We have focused heavily on for loops, but while loops are also helpful.